background music. Alright, so first thing we need to look at is answer the following question for the solid parabola. So that would be this parabola here on the left. What is the vertex? The vertex is going to be the point right in the middle that where it divides the parabola in two. So that point right there. Let's do some red. Red's always easier to see. So that point right there, the red. Okay, that point. So a vertex is both an x and a y value. So that's what you need to tell me. So that would be -5 and -2. Okay, that's where that point is. Next thing is, what is the equation for the axis of symmetry? Alright, so here is a little hint. If you're looking for the axis of symmetry, it is the x value of that vertex. Because remember, the axis of symmetry is the line that divides your parabola in two, because it's symmetrical on both sides. So that line I just made right there, that is your axis of symmetry. You need the equation. Now if you remember, vertical lines, or VUX, your equation is going to be x equals whatever that number is at the x value, and which happens to be -5, because that is our vertex. So axis of symmetry will be -5. So again, it's x equals -5. Now you need to, the question is, does the parabola have a maximum or a minimum value? Now remember, when it says value, we're talking about y value. Anytime you see the word value, we're talking about the y's. Okay. Does it have a maximum in? Well, let's look at it. It kind of slopes down and then goes up. So it's a valley, so that means it has a minimum. So yes, it has a minimum. What is it? What is the minimum y value? Now remember, we're only looking for the y value. And again, it's that y value at the vertex. So that's the nice thing about the vertex, is that it tells you a couple of things. So it's 2. So if you look back at the vertex over here at the top, the -5 tells us what the axis of symmetry is, and the -2 tells us what the minimum or the maximum is. Okay, so it kind of gives, once you find the vertex, you can find both of those. Now, what are the roots of the parabola? Well, remember, the roots are the same thing as zeros, solutions, and x-intercepts. So, find the x-intercepts. That's all we got to do. I see one here, and I see one here. And they are at -7 and -3. Okay? Now, what is the y-intercept? Okay, well, the y-intercept, I don't see it. Because if you go over to our graph, it doesn't really cross the y-axis. So how are we going to find that? Well, guess what? We're going to need the equation to find it. So, because if we have the equation, we can find the y-intercept. So, let's make the equation by taking our zeros, 7 and 3, and first make your two binomials. The first one's going to be x, and the second one's going to have an x. But the next part is the key part. So, if I plug in a 7 here, I have to figure out what number do I need to put next to it here in order for it to equal 0. And I put +7, because -7 plus 7 is 0. And I'm going to do the same thing here on the right side. What number do I have to put here so when I plug in -3, I get 0? Well, +3, because -3 plus 3 is 0. So now just FOIL it out. And there's our equation for that graph. Look at that. Now, if you guys remember, looking at the standard form of a quadratic, we know that C tells us what the y-intercept is. And that's why we needed to find the equation. Because if we go back to this equation over here, there's our C, 21, the y-intercept. Okay? So the y-intercept is 21. Okay? Now let's look at this next one. What's the vertex here? Oh, well, the vertex is here, right in the middle, and it's at 2 and 5. And if you remember, the axis of symmetry is x equals the x-coordinate of the vertex. So x equals 2. And does this parabola have a maximum in? Well, it seems to go up and then come down, so it has a peak, so meaning it has a maximum, highest point. And then what is that maximum? Well, we know that it's the y value at that vertex point here at the top, so it's going to be 5. What are the x-intercepts? Well, go back over to your graph here, and we've got it x-intercept there, and x-intercept there, wherever it crosses the x-axis, and it will be -1 and 5. All right. Now the y-intercept. Now this one, the graph clearly crosses the y-axis at some point, so we don't actually have to find the equation this time. It crosses right there at that point. So our y-intercept is going to end up being 3. Okay? All right, so go ahead and do the problem in the problem. Okay, now let's move on to the next one. This equation here is in standard form. And again, let me write standard form off to the side here. A plus ax squared plus bx plus c. That's the form it's in. Now remember, A tells us whether it opens up or down. Then the letter A. Now, letter A in this case is 1 or +1. And if it's positive, we open up. If it's negative, we open down. So in this case, it's positive, so it's going to open up. What is the axis of symmetry? All right, well, we're actually going to have to do a little bit more math to figure this one out. Now, to find that x value, the axis of symmetry, it's actually equal to -b over 2a. And remember, this is in your notes. If you go back to your notes where it says the standard form of a quadratic, it's right there for axis of symmetry, that little equation there. Okay, so now we take the -6 and plug it in. Or it's negative times the -6 over 2a. 2 times a is 1. I'm sorry, 2 times 1. And then negative times -6 is +6. And then 2 times 1 is 2. 6 over 2 is 3. And that is our x value. So the axis of symmetry is x equals 3. Okay. Now, what's the vertex? All right, well, we have the x value of the vertex, because that's just the x value we just found. So now we need to find the y value. And you do that simply by plugging in that number we just found back into your original equation. So I'm going to plug it in here. -6 times 3 plus 1. All I'm doing right now is plugging in the x to this equation here up here. Okay? And that's going to equal 9 minus 18 plus 1. 9 minus 18 is -9, plus 1 is -8. So there's our y value. So the vertex is going to be 3 and -8. Okay? What's the y-intercept? Okay, well, we just go back to the original equation, and remember C tells us our y-intercept. So C, the y-intercept is, just write 1. Okay? Now I'll have you answer a question off to the right. All right, now vertex form of a quadratic. A little bit different. So again, the vertex form, a little different, but it still gives us similar information. Now, if you remember, when we write down the vertex form, y equals a times x minus h squared plus k. And that's important to remember that minus, because it tells us that x is a liar. And that's going to be important when we find the vertex. Okay, so again, the a tells us the same thing in vertex form. tells us whether it opens up or down. In this case, A is negative, so this one's going to open down. Now about the axis of symmetry. Well, if you guys remember, the axis of symmetry is just the x value of the vertex. So we probably need to know what that vertex is. Now, if you remember, x is a liar, so whatever that number is, where h is, it's going to be the opposite. Because the original formula is x minus h, so really it's the negative, it's the opposite. Okay, so if this is positive 3, the x value is actually negative 3. Okay, so that's the x value, so it's going to be x equal to negative 3. And again, the vertex is going to be that same negative 3, and the y value is the k on the outside. Over here, the 5. Now remember, x is a liar. That whole idea does not apply for the number on the outside. But the number on the inside, next to the x, that does apply. Because it's next to x, so x is a liar, it's the opposite. Okay. Now if this, let's say this was x minus 3 in the middle here, then that would mean that this is a positive 3 instead. So whatever this number here is, again, in the middle where h is, it's the opposite for the x value. Okay? Now for the y-intercept, well, the vertex form doesn't really tell us what the y-intercept is, so what we have to do is convert this back to standard form. And it's pretty simple. All you have to do is multiply all this out to get back to standard form. Let me show you how to do that. So let's write it out. Negative 2. So over a little bit. Times x plus 3 squared plus 5. Okay, let's multiply this out. First thing, remember PEMDAS, follow your order of operations. Let's do the parentheses first. And then here we've got x plus 3 squared, so that means x plus 3 multiplied twice. So let's FOIL that. And remember, you can't distribute the 2 yet. Don't do that just yet. So let's FOIL the x plus 3 times x plus 3. So we got x squared plus 6x plus 9. Now let's distribute the 2. So now we get negative 2x squared minus 12x minus 18 plus 5. So all I did there just now was distribute that 2, or that negative 2, in case you're wondering. Alright, so now let's combine like terms. And the only thing we can combine is this last 18 and 5, negative 18 and 5. So our final function is going to look like this. Negative 18 plus 5 would be negative 13. So our y-intercept ends up being negative 13. Okay? Alright. So I'll have you do the problem to the right. Now, let's go down here to writing quadratics from zeros. So it's saying write a quadratic function for both graphs. Now it's referring to the graphs that we just did that are above, these first ones up here. So what I'm going to do is I'm going to write down those zeros, or the x-intercepts, roots of the parabola. So the first one, we actually already did the first one. That was this part here. We found that equation. So that is actually how we find the zeros for that one. It was x squared plus 10x plus, or sorry, minus, no, that's plus 21. Okay, and we found that from the roots 7, negative 7, and negative 3. So rewind the video if you missed that part, or if you didn't understand that, or you want to see it. So let's look at the second one. So we need to know the roots of the second graph, the dotted one or the dashed one. And the roots are over here, negative 1 and 5. Negative 1 and positive 5. So remember, the first thing we do is write our binomial parentheses, put an x in front in both, and then you need to think, what number do I need to put here so that when I plug in this negative 1, it will be 0? Well, it will be plus 1, because if I plug in negative 1, it will be negative 1 plus 1, which equals 0. So we're good to go there. Same thing here. What number do I need to put here so that when I plug in this 5 into the x, it will equal 0? Well, in this case, it's going to be negative, because 5 minus 5 is 0. Once you have that, just FOIL it out, and then you'll have your equation, or your quadratic function. Alright, and there you go. And there's your two functions for your quadratic function. Oops, sorry. Okay, now write a quadratic function with the roots 5 and negative 6. So we're going to do the same thing here. Okay, so first, make your binomials, put an x in the front in both. The first one I'm going to do for the 5, so it would have to be, what number do I have to put here for this to equal 0? When I plug in 5, it will be negative 5, because 5 minus 5 is 0. And what number do I have to put here? Plus 6, because when I plug in negative 6 plus 6, it equals 0. And then just FOIL it out. Nope, sorry, that's actually positive x. Alright, so now the second one, or the third one I should say, write your parentheses, and you need to write x in the first one, x in the second one, and now we have 0 that I'm going to plug in here. So what will I put there if I want this to equal 0? Well, it's already 0, so I don't need to add anything. So I'll just put a 0. Actually, I don't even have to put that. I can just put x. Because if I plug in 0 to x, it's going to be 0 no matter what. Okay? So now, and I'll rewrite it here in a second. What do I have to put here? I put plus 7, because when I plug in that negative 7 there, it will equal 0. So now what this should look like is x times x plus 7, and then just multiply that out to get your function. So x, distribute the x, I get x squared plus 7x, and there's my function. Done. And as you can see, there's no c value, so the c value is actually just 0, but we can't see it. It is there, but we can't see it. Alright, go ahead and do the problem to the right. Okay, now this next one says, write a quadratic function with the following x-intercepts. Well, guess what? We're doing the same thing. Remember, x-intercepts, roots, solutions are all the same. So again, here's our roots, 4 and negative 3. Draw your binomials, put x in the front. We're going to have 4 here in the front, and it needs to be negative, so that when we plug in that 4, it'll be 4 minus 4. And then over here, this needs to be plus 3, because when we plug in negative 3 plus 3, that will equal 0. And then just FOIL it out. And there's our function. And I'll have you do one more. Alright, let's move on to this here, solving quadratics by square roots. Okay, I'm going to choose a new color here. Let's do this purple color. That's cool. Okay, so we're going to use square roots in order to solve this. Now, just a little note, when we square root something, do not, or don't, forget the plus minus. Okay, because if you square something, there's two solutions, not just one. It'll be a positive one and a negative one. Now, this one to the left, what we need to do is I need to move this negative 125 to the other side. So let's use our algebra and add it to both sides. So now I get 5x squared equals 125. Now, the next thing you need to do is you do not want the number in front of the x squared to be bigger than 1. Don't want this number here to be bigger than 1. So let's get rid of it by dividing both sides by 5. So I'm going to divide this side by 5 and this side by 5, and it makes life easier as well. So now I end up with x squared over here, and then 125 divided by 5 is 25. Now the last step here, again solving quadratics by square roots, that's where the title comes from, is that we're going to take the square root of both sides. Now if you square x squared, that just becomes x. And if you square 25, that's 5. Now remember though, this, if you take the square root of something, you need to consider the plus minus, because you can have two solutions. So it's going to be the square. It's going to be x equals to plus or minus 5, or you can say x equals 5 and negative 5. Okay, and there's your two solutions. Now let's do this next one. Okay, again, move the c term, this is actually the c term, move it to the right side by subtracting it here in this case, because it's positive. So now we have 2x squared equals negative 128. And remember, the a cannot be bigger than 1, so we need to get rid of that a, or make it 1. So divide both sides by 2. And then we will end up with x squared equals, what is that, 64? So it would be negative 64, because we got a negative there. So now, take the square root of both sides, and you end up with x squared, I'm sorry, not x squared, x equals, remember, plus or minus. Now, before I move on, sorry, I just got interrupted. Now, when you take the square root of a negative number, you need to remember that's going to end up giving you an imaginary number, because you take the negative out, and that becomes I. Okay? And then, so let's just take out the I. Let's do this one step at a time. Actually, you know what? Let's do it this way. Let's take the I out first, and then we'll keep the negative 64, under the square root. So once you take out that negative, it becomes I. And now take the square root of 64. Now you end up with x equals plus or minus the square root of 64 times I. And the square root of 64 is 8. So we have plus or minus 8i, or 8x equals 8i, and negative 8i. So we have two imaginary roots. Alright, now let's do this next one. We need to add 160 to get rid of it. So we're going to add 160, I'm sorry, to move it to the other side, not to get rid of it. Now we're going to end up with 4x squared equals 160. Now again, that 4, the a, is bigger than 1, so we need to make it 1 by dividing it by itself, 4. And we are left with x squared equals 40. Now we're going to take the square root of both sides. Actually, I don't need to do red anymore. You guys seen it enough. Square root both sides. Now, this doesn't really evenly come out as a square root. Okay? So, what we're going to do is use our little birthday cake method to break down a number that's not a perfect square. And I'm going to do divided by 2. Divide by 2. I'm looking for all the prime factors here of this number. Divide by 2 again. I get 5. And the last prime number I can divide is 5. So my factors are 2, 2, 2, and 5. So what I've got here is then the square root of 2 times 2 times 2 times 5. Now remember, if you remember, the index there is 2. If we can't see it, it's 2. So what I need to do is circle groups of 2 and take one of those out when I take the square root. And if I square root, that means I'm going to have to do plus minus. So I take that 2 out, end up with this. And I basically, the 2 and the 5 just stay underneath the square root, and then combine back to become 10, because it's 2 times 5. So again, just to quickly, I broke down the 40 then into the smallest prime numbers. Then I circled a group of 2, because the index is 2. I took one of those 2's out, and I was left with a 2 and a 5, and then I multiplied the 2 and a 5, got 10. So then this would also end up being 2 times the square root of 10, and negative 2 times the square root of 10. Now on the test, I may ask you for the decimal, or round to the nearest hundredth. So what you'll need to do is actually do this square root of 10 and then multiply it times 2. So if we, okay, so now we're going to do the square root of 10, square root of 10 times 2. So it's 6.32, if that's rounded out. Actually, no, it's not. It's 6, because we have the 5 will change the 4 to a 5, and then that 5 will change the 2 to a 3. So it's 6.33. So you would write your answer as x equals 6.33 and negative 6.33. Okay? So that could be two possible answers depending on what I ask for. Alright? So go ahead and do the problems to the right. Now let's do some solving a quadratic by factoring. Alright, so we need to use our principles of factoring. So what you should do is, if you don't remember how to factor, go back to your notes in the page that details on all the different ways how to factor. And there's actually a note in your unit 4 that details how to solve a quadratic by factoring, and that will help as well. That'll probably be more useful to you to go through these problems. Now, x squared plus 6x. Let's factor that. Well, all we can do here is factor out an x. So let's take an x out. I'm left with this. So I took an x out of the x squared and an x away from the 6x. And I need to figure out, what do I plug in here to make this equal 0? Well, simply 0. If I plug in 0 there, it will equal 0. What do I plug in here to make it the whole function equal 0? Well, negative 6. Because negative 6 plus 6 is 0. So there's my solutions. Okay? Now let's go to the next one to the right. This one's very similar. The only common factor between these two is x. So let's take out an x. I'm left with 36x minus 25 equals 0. Now the first one's easy. I plug in a 0 here, so that's my first root. However, what do I plug in here? This is a little different. So what I'm going to do is I'm actually going to pull this whole part, this whole thing, off to the side and set it equal to 0. Because I need to find what number will make this equal 0. And it's obviously going to be a fraction. So if I set it equal to 0 and solve for x, that will tell me what will make it equal 0. So let's add 25 to both sides to isolate x. 36 equals 36x equals 25. Then divide both sides by 36. X equals 25 over 36. Now there's no common factor between 25 and 36, so I can't reduce that fraction. So that's my root. So then the roots are 0 and 25 over 36. Okay? Okay, now the next one. Now the next one is, what we want to do here is we want to FOIL this out. Because we have 3 terms, a quadratic with 3 terms, and the leading coefficient, a, is equal to 1, so we can just do a reverse FOIL. So, or if you guys remember, we can do what you guys like to call magic X, or the diamond, whatever you want to call it. We'll put the last number, C, here, and we'll put the B here. And basically we have to figure out what 2 numbers both multiply and equal negative 15, but when we add them, they equal negative 2. Well, let's see. How about a 5 and a 3? Well, I know that one of them has to be negative. In order for it to be negative 2, we're going to have to make the 5 negative. Because negative 5 times 3 is negative 15, and then negative 5 plus 3 is negative 2. Okay, so there's our 2 factors. So now, remember, these are the zeros, so in order to make, so now this is x minus 5 and x. They're not the zeros, I apologize, I shouldn't have said that. Because we have to find the zeros once we plug in those numbers. Now, what number do we have to plug in here to make a 0? 5. Because 5 minus 5 is 0. What number do we have to plug in here to make it 0? Negative 3, because negative 3 plus 3 equals 0. And there is our solutions, our roots, also the x-intercepts. Alright, now let's go on to this one down here. Now this one, it's looking like I need to move this 42, negative 42, back to the other side. So we're just going to add a step here. Add 42 to both sides. Get it to look like this. Alright. Do it again. Let's reverse FOIL. What numbers multiplied equal 42, but when added equal negative 13? Well, negative 6 and negative 7 multiplied equal positive 42, but when you add the two, they equal negative 13. So we get x minus 6 and x minus 7. And then to find our roots, it would be 6 and 7. So I plug in 6 there, it equals 0, and if I plug in 7 there, it will equal 0. Alright. Okay, this next one. Well, we've got a coefficient that's bigger than 1, so it's going to be a little bit more tricky. So this time we're going to need to use the X box method. Okay, the X box method is we make our magic X, and this time instead of just putting 4, you're going to do C times A. So negative 4 times 2 is negative 8. And then you still put the B on the bottom, which is negative 7. So now, find 2 numbers that multiplied equal 8, negative 8, and added to equal negative 7. Well, how about negative 8 and 1? Because negative 8 times 1 is negative 8, and negative 8 plus 1 is negative 7. Okay, but we're not done there. When you have, again, when we do the X box method, now we have to make the box. And the first thing you write is the first term of your original function, 2x squared. And then the next thing you're going to do is write those 2 numbers you just found, the negative 8 here, and it's going to be negative 8x. And then the 1 over here, 1x. And then the last thing you do is write the last term from your original function, which is negative 4. Now you have to figure out what numbers go here on the outside. Alright, well, let's put a 2x here and an x here because 2x times x is 2x squared. So now, for this number over here on the left, what number times 2x equals negative 8x? So that'd be negative 4. And over here on the top right, what number times x equals 1x? 1. So then now everything in the factored form will look like this. You take your top ones, your top two numbers, and it becomes 2x plus 1. That's your first binomial. And then you take the ones on the side, and that'll become the second binomial, x minus 4. Still not done yet. Now we need to figure out what numbers do I plug in here to make these 0. Well, for this one, I need to write it off to the side because it doesn't quite work out perfectly. It's going to end up being a fraction. So set it equal to 0 again. Subtract 1 from both sides. And then we'll get 2x equals negative 1. And then x is equal to negative 1 over 2 after I've divided both sides by 2. I just kind of skipped a step there. So that's my first root, negative 1 half. And then the next one is a lot simpler. You just plug in 4 here to make that equal 0. So then our roots are negative 1 half and 4. Okay? Okay, now here's the last one for solving by factoring. This is another one like the last. Now I just kind of skipped a step here. I added, sorry, that should be plus 15. I added 15 to both sides to get it back in this form. We're going to do the Xbox method. 15 times 6 on the top. 15 times 6. So 15 times 6. So 90 on top. And then you put the 19 on the bottom. So then, I know these are big numbers, but it's a lot easier than you think. What two numbers multiplied equal 90, but add to 19? Well, 9 and 10. Because 10 plus 9 is 19, and 9 times 10 is 90. Okay, so make our box. Put the first term of your function here, so 6x squared. And then you're going to put the two numbers you just found, 9, which becomes 9x, and 10, which becomes 10x. And then the last number in the bottom right corner you're going to put is the last number of your function, which is 15. Now, this requires a little bit more thinking. I have to think of numbers that will multiply to equal the 6x squared. So I know that down here I'm going to have to multiply probably a 3 to get 9. So I'm going to put 3x here and 2x here, because 3x times 2x is 6x squared. And then I have to say to myself, what times 3x equals 9x? Well, that's just 3. And then go to the top right. What times 2x equals 10x? 5. And there is our binomials. 3x plus 5 and 2x plus 3. Now, I'm going to have to pull both of these off to the side. So 3x plus 5. And there's a quick way to do this. If you want to know, just come see me. But I just want to show you the tried and true way so that you guys don't get it wrong. So then subtract 5 for both sides. Get 3x equals negative 5. And then divide both sides by 3. I get negative 5 over 3. And do the same thing over here. Set the inside equal to 0. Subtract 3 from both sides. I get 2x equals negative 3. Then divide both sides by 2. And I get negative 3 over 2. So, my roots, my solutions, are going to be x equals negative 5 over 3 and negative 3 over 2. There we go. Go ahead and do the problems to the right. Okay, the last one is going to be, sorry, not the last one, the second to the last one, third to the last, sorry. It's going to be solving quadratics by completing the square. Alright, so, to complete the square, the first thing you want to do is check, is the a value bigger than 1? Now, in all these examples, they're not. If they are, you need to divide everything by that a value. And if that starts to get messy, then you probably need to use a different technique. Okay? But if it divides out evenly, then you could probably use this technique. Okay, so as long as your a value, the first term here, is 1, then you're good to go. You can just go ahead and start the completing the square method. Okay? So, first step is you want to take your c, the last number to the right, and move it over to the right side of the equal sign. Now do that, just simply subtract it from both sides. In this case, subtract it. You get negative 27 on the other side. So now you'll have x squared plus 14x, and then I'm going to leave a space here because I'm about to add a number for the completing the square, and then you have negative 27 on the other side. Now the number you're going to put here is going to be equal to b over 2, all that squared. Okay, so what I'm going to do is put a box here, and you're going to add whatever that number is. So what goes in there again is the b over 2 squared. So the b here is 14, so it'll be 14 divided by 2 squared, and 14 divided by 2 is 7. 7 squared is 49. So 49 goes here. Now again, just like any other problem, if you add something to one side of the equal sign, you have to add it to the other. So we're going to do the same thing over here. 49. Add 49. Now the next step, what you're going to do is you're actually going to factor that on the left side. Okay, you're going to reverse FOIL. So this is going to end up be equaling x plus 7 and x plus 7. How do I know that? Without doing the x diamond method. You can do the diamond method, but you always know that the number here, which in this case is 7, is going to be the b over 2. So as you can see, 14 divided by 2 is 7. So that's where the 7 comes from. And then you're going to add 27 plus 49 on the other side, which is 22. And combine both the x plus 7 and x plus 7 because they're the same, so we'll make it squared. Now you're going to use the method, the square roots method that we just talked about a couple of sections ago, and you're going to square both sides. And remember, if you square root something, don't forget the plus minus. Okay, so now we are going to end up with x plus 7 over here, and then plus or minus the square root of 22. Now what I'm going to do is I'm going to move that 7 over to the other side, so subtract 7 from both sides. So now I've got negative 7 plus or minus the square root of 22. Now 22, you can't really take out anything there. So what I'm going to actually do is convert this to a decimal. Alright, so let's go back to our calculator. Now the square root of 22 is 4.69. So 4.69. So if we go back to here, it says negative 7 plus that number. So, let's see, where's the negative? I think we'll just do that. Okay, negative 7. We're going to do add 4.69. We get negative 2.31. So that's our first number. And then the second time around, we're going to subtract it. So negative 7 minus the same number, 4.69. Negative 11.69. And there's our two solutions. Okay, so the next one. Again, let's add 11 to both sides. And we just have x squared minus 4x on this side, and then 11 on the other side. And then I need to complete the square. Negative 4 divided by 2, all that squared, it's going to be negative 2 squared, which is 4. And we're going to add 4 to both sides. Now let's reverse FOIL. And I'm going to jump ahead a step here, because I know that both of the binomials are going to be the same. That's the point of completing the square. And we're going to have x minus 2 and x minus 2, so it's just x minus 2 squared. And then the other side will be 15, 11 plus 4. And then again, let's square root both sides. I get x minus 2 here, and then plus or minus square root of 15 here. And then I need to add 2 to both sides, and I get 2 plus or minus square root of 15. And I can't really do anything with the square root of 15 unless I want to find the decimal. So I'm just going to write out two answers like this. 2 plus square root of 15 and 2 minus square root of 15. And there's my two solutions. Okay, the last one here. Now we already have the c on the right side, so that saves us a step. So now, just leave a little space here to work. Draw my little box for completing the square. And it's always plus. So now 16 divided by 2 squared, which is 8 squared, so it's going to be 64. So now here, again, remember that the number in here will be b divided by 2, so it would just be x plus 8 squared. And then negative 49 plus 64 is 15. And again, square root both sides. End up with x plus 8 over here, plus or minus square root of 15 here. Subtract 8 from both sides. X equals negative 8 plus or minus negative 15. Square root of 15. And then the final answer that you would write here is x equals negative 8 plus square root of 15 and negative 8 minus square root of 15. And if I was to give you the decimal here, it would be negative 8 plus the square root of 15, which is equal to x equals negative 4.13. And let's do it now by doing negative 8 minus square root of 15, and that will be negative 11.87. And there's two ways to write this solution. Go ahead and do the problems to the right. Okay, now finding the discriminant. Finding the discriminant. Now, the left side here is going to be pretty simple. Finding the discriminant, all you're using is this formula here. B squared minus 4 times A times C. That comes from originally from the quadratic family formula down here, which we're going to work with in a second. But all we're doing is evaluating for this here. So all you do is simply just plug it in. If I say find the value of the discriminant, just plug it in. Okay, so in this case, B is 8, so it'll be 8 squared minus 4 times A, which is 6, times C, which is negative 7. 8 squared is 64, and 4 times 6 is 24, times 7, let's do that on the calculator real quick. Let's see. So we had negative 4 times 6 times negative 7 is equal to 168. And then 64 minus 168 is negative 104. And that's the discriminant. That's it. These are very simple. And then for the next one, plug in the 4. So 4 squared minus 4 times a is 2, and c is 2 as well. So now 4 squared is 16, minus 4 times 2 is 8, times 2 is 16, so then our discriminant is just 0. Okay, now we're going to do the same thing, except we're going to find the discriminant, but now we need to know what types of solutions does the equation have based on that discriminant. Well, if you go back in your notes, if you remember, if I have a negative discriminant, that is going to be 2 imaginary solutions. If my discriminant is 0, I will have 1 real solution. Not solutions, just solution. And if my discriminant is positive, I'll have 2 real solutions. Okay, so let's just plug in the numbers, and then we'll figure out which solution, what it is. Okay, so our b is negative 6, so negative 6 squared minus 4 times 9 times 8. So that will be 36 minus, I can already tell you that it's going to be negative because that's a big number we're about to subtract. 4 times 9 times 8 is 288. And then 36. Now you could just stop here, honestly, and figure out, well actually no, on the test I want you to continue through. But if, let's say in the grand scheme of things, you were just trying to figure out if it's, let's say you're on IXL or something, and you just want to know if it's negative or positive or 0, you can see right away it's going to be negative, because you got a big number you're about to subtract. But for the test, for the purpose of the test, I want you to actually find the discriminant and then tell me what it is. So now we've got negative, so that means we're going to have 2 imaginary solutions. Alright, now the next one, we've got 4 squared minus 4a, which is 4 times a, which is 4, times c, which is 1. Then we get 16 minus 16, so we get 0. 0 means 1 real solution. Awesome. Okay. And then, what's the last one? Plug it in again. Negative 4 squared. Oops. Negative 4 squared minus 4 times a, which is 8, times c, which is negative 2. We get 16 minus, let's see, 4 times 8 is 32. Times 2 is 64. And we've got 2 negatives here, so that will make it positive. So we're going to end up with a positive number here. We'll end up with 80. 64 plus 16. So that means we're going to have 2 real solutions. Alright. Do the problem to the right. Okay, last one. So now the quadratic formula. We all remember our favorite and special formula. It is b, negative b, plus or minus the square root of the discriminant, which is b squared minus 4 times a times c, all over 2 times a. Now the nice thing about this formula is that once you have it, you just plug in the numbers and then solve for it. So we're going to plug in for b, negative 2, so negative 2 times negative times negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 7, times negative 16, which is our c, all of that over 2 times the a, which is 7. So now just evaluate it. So negative 2 times Negative is 2. And then let's see, on the inside here we've got 4 minus, let's see, 4 times 7 is 28, times 16, 448, and that's going to be positive. So we get 4 plus 448, and then 2 times 7 on the bottom is 14. And we end up with 2 plus or minus 452 all over 14. So now, with quadratic formula, I'm going to ask you to round it to the nearest hundred. Okay, so just simply take your calculator and multiply and add and divide all this out. Okay, so the first one, I'll show you how to do it here. It's going to be 2 plus the square root of 452. So let's take the square root of 452. And we can just, we don't want that. And we can just add that to 2. And then it's all that over divided by 14. So 1.66. Our answer there. If we do plus, so that time I added, so this time we're going to do subtraction. So 2 minus square root of 452 over 14. Let's do square root of 452, which is equal to 21.26. 21.26, so that means 2 minus 21.26. That over divided by 14 is negative, let me double check, negative 1.38. So remember, we've got to round to the nearest hundredth, so negative 1.38. And there's our two solutions. All right. Now let's do the same thing over here. So again, use our formula, negative b plus or minus b squared minus 4 times a times c all over 2 times a. So now we have negative 8, or negative times 8, which is just negative 8, times b squared. I'm going to kind of skip a couple steps here. So b squared is 64, minus 4 times a, which is 8, and then 8 times negative 6, times negative 6 is 48, or negative 48, and I've got two negatives there, so that's going to make a positive. So I'll have 48 here. And then 2 times a, which is 2 times 2, which is 4. 2 times 2 is 4, so that's the bottom. And then negative 8 plus or minus the square root of 64 plus 48, which is 112. And again, I want you to figure out the decimal answer here, and I'm just going to do some on my calculator on the side. So negative 8 plus the square root of 112 divided by 4. And that will be 0.65. Now let's do minus. So now we're going to do negative 8 minus the square root of 112 divided by 4. And we get negative 4.65 once it's rounded off. Alright, so go ahead and do the problems that are in Ed Puzzle.